The universe is expanding. Not only that, but it is expanding faster due to the presence of this mysterious substance which has been named by the scientists as dark energy. Now, think of dark energy as the evil counterpart to gravity, an anti-gravity force that puts negative pressure and fills the universe that stretches the very fabric of space-time. But before we get into dark energy, let's first talk about the expanding universe. My name is Siddharth and you're watching The World of Science. The universe started expanding from an extremely hot and dense state about 13.8 billion years ago. Our universe has been getting bigger and bigger ever since. Nearly every galaxy we look at is zipping away from us, caught up in that expansion. This expansion, though, is even weirder than you can imagine. Things aren't actually moving apart. Instead, the space between them is getting larger. Confused, right? Let me explain. Imagine you and your friend are standing next to each other. Now, you guys are still in the same spot, but the flow between seems to be growing. You two aren't technically moving, but you do see each other moving apart. And that's what's happening with our galaxies and everything else in the cosmos in all directions. Astronomers expected the expansion to slow down over time. You might wonder why. The answer is gravity. Anything that has mass or energy has gravity, and gravity tries to pull stuff together. Plus, it works over the longest distances. Even you watching this are exerting some gravitational force on the farthest galaxy in the universe. It's a very tiny force, but it exists nonetheless. As the space between the galaxies grows, gravity tries to drag the galaxies back together, which should slow down the expansion. So, if we measure the distance of faraway galaxies over time, we should be able to detect if the universe's growth rate slows down. But in 1998, a group of astronomers measured the distance and velocity of many galaxies using bright exploding stars as their reference points. They found out that the expansion was getting faster, not slowing down, speeding up. But at some point, dark energy took over gravity and the expansion sped up. It's like our universe is on a giant roller coaster ride, but we're not sure how steep the track is. Researchers started looking for signs of accelerated expansion, and guess what? They found it. Everywhere. They saw it in the large-scale structures of the universe, like galaxies, galaxy groups, and clusters. They even saw it when they looked at the cosmic microwave background, a baby picture of our universe from just a few 100,000 years after the Big Bang. If you thought this roller coaster was wild, hold on, because things are about to get really weird. Clearly, we're missing something here. Gravity wasn't the greatest influence on matter and energy across the largest scales of the universe. Something else was. And the name we've given to that something else is dark energy. We don't know what dark energy is, and we have never directly detected it. But what we do know is that there's a lot of it. And I mean a lot. Dark energy makes up more than 2/3 of what's out there in the entire universe. That's a lot of universe to have stayed a mystery. Researchers have come up with a few dark energy possibilities. Einstein discarded an idea from his theory of general relativity about an intrinsic property of space itself. It could be that this bit of theory got the dark energy right after all. Perhaps instead there is some kind of strange energy fluid that fills up space. It could even be that we need to tweak Einstein's theory of gravity to work at the largest scales. That would revolutionize the entire physics as we know it. Now, you might be wondering, why is dark energy so important? Because understanding dark energy is the key to building an accurate model of how the universe evolved over time, and that includes the shape it takes and how it will end. Both the origin and the fate of the universe are determined by its critical density. which is the average density of matter required for the universe to just halt its expansion. But that's only after almost infinite amount of time. If matter or energy density of the universe is equal to critical density, then in terms of geometry, our universe is flat like a sheet of paper. In a matter-dominated universe, the critical density is between the density required by a collapsing heavy universe and the density of a lighter universe that expands forever. The total content of the universe without dark energy is only around 30% of what is required for a flat universe. That's the kind of geometry the universe should have if created by the Big Bang. This is because early inflation should have smoothened the universe geometrically like a sheet of paper. The addition of dark energy to the universe's mass energy budget tops it up enough for the universe to be flat. And in the simplest models of cosmic inflation, it brings the density of the universe close to the critical density. Before the introduction of dark energy, astronomers had assumed that the attractive influence of gravity would overwhelm the expansion of the universe. This could lead to a few possible scenarios on how the universe would end, one of which is the Big Crunch, which suggests that the universe will begin to contract and collapse in on itself. To know more about the Big Crunch and other possible scenarios as to how the universe would end, check out this video. But then the acceleration of the universe completely dispels this idea. If dark energy continues to accelerate the expansion of the universe, then instead of the Big Crunch, its fate could be a Big Rip. This is a scenario where dark energy becomes dominant over all four fundamental forces of universe: gravity, electromagnetism, strong nuclear force, and weak nuclear force. It would basically break and rip apart everything that is bound together by these forces, be it galaxies, planets, people, and even protons and neutrons that make up atoms. So what are your thoughts on dark energy? Let us know in the comments. If you want us to keep creating such content, could you please show your super support by using the super thanks option? Even the smallest contribution that you make will go a long way. It's people like you that help us make science more fun and easy than it has ever been. Thank you so much. This is Siddharth signing off. Make sure you subscribe to the World of Science. Until next time, stay scientific.